Looks like my mic wasn't fully plugged in. So we're good now. It's one of those streaming things. You're not a real streamer if your mic doesn't break every single stream. It's fine on Discord and everything. It's only streaming. Like on Discord, I'm always the Discord and all the other video conferencing apps. I'm always the one who actually has their sound working. All right. So let's start thinking about, we have a proof of concept working. How do we actually get this to be what we want it to be? Always. So now that we're not attempting to do the searching of files in a build script, we no longer actually have to write out to something like a toml file. We can just give back a struct. That's probably the best idea. The question is, there's not really and I've looked this up for when I was building my own scripting languages, if there was actually a standard for how you return just a struct and not a pointer to a struct, and there's not actually many standards on that at all. So I think if we are to return a struct, it has to be through a pointer, or we need to have them pass in an already existing struct. I think what we should probably do is return a struct. So struct, we'll call it module metadata. For now, we'll just have these be strings. Problem is, vector doesn't really work for passing data between here and there, so we're gonna have to create our own struct type that actually does work between them. So we'll call this C vector. Let's actually make it a generic. So do you put it there? No, we put it after the type name. So then pointer, mutable pointer definitely, to a type, and length is usize, and we also want this to be in a CABI data layout. So, and then if we go to here and we say we're returning a module metadata mutable pointer. I don't actually know how you make a new pointer in Rust. Do you just say new? Probably has to be in an unsafe block, doesn't it? Yeah, we can dereference a raw pointer. How do we allocate a raw pointer? Alright, so the way I probably want to do this is, like it says here, by consuming a box. But we do have to do the work of, obviously this is mostly unsafe behavior. So how do we interact with that from safe code? Or how do we want to interact with this from safe code? So we can into raw. Oh, it's a... Okay, and it's mutable by default, that's nice. Oh, it's unnecessary? Okay, is it only interacting with pointers? It's not creating them. Yeah, this is fine with creating a pointer. So it's not that we can't use pointers at all in regular Rust. It's that we just can't interact with them. That's good to know. That into raw it's very good to know. So that gives the struct to C, but it doesn't create any destructors, I think. Because yeah, we get this C vector here. So if we make an implementation of the drop method, length, capacity. This all looks correct, though it doesn't have any way to deal with capacity. We'll just assume that this is always exactly the size, exactly length, without any extra capacity, I guess. We just drop the vector. Is it possible to just call delete on the pointer though? Well, I guess technically they have malloc free. Libc free. So is all Rust stuff allocated with malloc and free in the backend? It is not like C++ where we have to always call it with new and delete. Malloc. Right, but there's a little bit of extra stuff that new and delete does that basically you're not supposed to mix them. And you can sometimes get an error if you try to delete something that was malloc or free something that was nude. So what I think is best practice is we could do two different things. Right. We could do could do this two different ways. Either we just say, okay, all of our C++ code just never manually frees stuff passed to it from Rust. Instead, you call a Rust function to free stuff, and I think that's the more common solution. The other solution would be to instead have attempt to call, I think it's, no. What was the... It's like Rust malloc, libc malloc. Oh, do I have to include libc as a dependency? I probably do. But this is probably interoperable with whatever libc that the rest of the project is working with. So if I say libc, no documentation. So this is just regular malloc. And if I use this on the Rust side and then free on the C++ side, I feel like that would be fine. Of course, then I wouldn't be able to do this, but that's fine. It does mean there will be a lot more copying if I go this route. Okay, we'll just go with the call the Rust API thing for deleting stuff. Okay. Can you no mingle extern implementations? Not all traits implemented. Okay. Can you expose implementation functions to C? I probably have to call or create wrappers. Yeah, I'll probably have to create wrappers. So we have to do the whole mingle. Free module metadata. And then We just call drop. I mean, we could just leave it like that, but, and then that, we would also call this drop function, I believe. There's no reason it wouldn't. Yeah. Okay, so it does catch on that this is a template. I'm kind of wanting to make this myself now, just because that would allow me to make the API a lot cleaner. But we'll just live with it for now. Let's implement a drop method for this. That way we don't have to do that. Well, drop would be called automatically on them, right? On members. Self.functions cannot move. Right, I know we can't move self. We can't move functions? Oh, right, because then functions would be empty, leaving it in an invalid state. That makes sense. So we'll just assume that drop gets automatically created, and then it calls this. I mean, for us to be completely safe, it would need to do that. I think. So we don't want to do vec from raw parts. Instead, we want to do let data equal box from raw, and then do we want to use vec? Or malloc and whatnot? Right, I'm thinking about that. Right now I'm just figuring out how do I allocate it in the first place. And we will want to store capacity here if we do end up just using vector. You know what? Let's not reinvent the wheel. Let's just use vector behind the scenes. Create a new. Okay, so that creates a single pointer. Oh, we want length here. Now, the tricky thing is how do we get it to not drop this? It's probably an unsafe function. It's like we have into raw. Can we say vector into raw? No. Standard mem forget. Takes ownership and forgets about the value without running as destructor. For FFI, which is what we're doing. It says manually drop is typically preferred. Okay, so that's for actually cleaning it up. All right, so this does look like what we want, and it's also good to realize that we probably need to run that on this function here. Forget return. Because going off of that logic into raw consumes the box. Wait. Okay, so that actually, the box is consumed. So we don't need to, yeah. Don't actually need to worry about that being cleaned up. We do have to worry about this being cleaned up. Forget data. Can we call forget whenever? It's just calling manually drop behind the scenes. Mostly prevents double free because we disable doing else. And forget doesn't allow this because it consumes the argument, forcing us to wait. Consumes it. Then oh, it's because I have this in an unsafe block. That's why it's not throwing an error. But if forget consumes the data, why isn't this throwing an error? There it is. Borrow move data. It just took us a little bit to catch up to that. So we do actually want to call this we do want to forget after setting this because this consumes the value. Variable does not need to be mutable. Oh yeah, because we're just passing it. Immutability is based on the caller. Interesting that we can get away with that much in safe rust. I thought that it would be a lot more strict about that stuff. Back from raw parts. Its traits were not specified. T clone. Okay. Would I put that on here? No. T has default. And copy, so that do I need to set this on the implementations as well? Or only on the implementations? All right. Let's see, for these, could resize use the move attribute as well? If it doesn't implement copy? Their implementation of this with move. Anyway, it is a good thing to know that you can just put it here. Instead of having to do the where. It takes care of reserve, resize. We probably want push as well. Okay. For now, we won't be needing to edit these from the C++ side. So I think, well, we should probably implement index as well. Is it called index? Okay, so we have index and index mutable. Rust trait for we're missing the using, I think. Okay, so we have to deal with lifetimes. Is that how you do it? Actually, let's just look at the vector implementation for index. So it returns a slice index. Probably don't want a slice index though. So if I go, did I say data 5, for instance? Okay, so it is this slice index. Okay, we're just going to copy how it works. I'm gonna say self output index. I don't want to edit that. Function slice index of t. Oh. That's weird. The highlighting was hiding that. Not constrained by the implementation trait. Index I. Okay. So we're returning an I. Oh, so this is the actual index type. Okay. So we can actually use stuff like an integer or a... Okay, that makes sense. That's how we deal with that. And we can just call our from raw parts. Let's also implement mutable indexing. Actually, does self need to be mutable? Okay, it does. Actually, we should be able to get away with the... Oh, I probably need to... No, it's still using the regular slice index. Index. Oh. Must be index mutable. It just doesn't return a mutable reference, does it? Yeah, we're just returning a slice. Okay, so there's a mutable override. There we go. So that's most of what we need to use this as a regular vector behind the scenes. And using this as a slice means a slice reference. Okay, so that's not getting cleaned up. Thank you. I'm glad people actually enjoy watching it. Some people actually enjoy me just insanely muttering to myself like, why isn't it working? So that should be all we need. Okay, it's fine that we have capacity there. I think there's a setting we can set that will make it automatically create destructors. What's this with standard types? Is that what I've been looking for? See, bind gen. So yeah, I did actually make this myself over the summer, like 2 years ago. So it's like, it's starting to fall apart. Like you can see, like we got the LED strips are starting to give out in some places and flicker a little. I don't know, it adds to the charm. I'm honestly surprised it's held up this long. Yeah. The fun thing is, I think it's because the LED strips, like the actual LEDs are like separating from whatever you call the thing underneath them. So if you actually press it together, it still works. But if you let go, it like turns off. So you can like press it and it still works. Let's see, cbind gen. Types, and we want this down here. That's interesting. I'm not seeing documentation for with standard types. Does this just add them to... add them to the header file? Maybe. I'm not sure. We'll add it there just in case it does something. We don't need to have it include the string library though. I'll probably separate this out into a different module at some point. This is just generic Ubuntu, so nothing too fancy. I did run Arch for a while, but installing Vulkan just wasn't working and various other things, so like, you know what, let's switch to something that will just work. Okay, I don't think we need to expose ways to interact with this, though. Let's actually name this to something like BraneEngine vector. That way it doesn't get confused with any other like FFI types. I wonder what else is in here. Utilities related to FFI bindings. Okay, so it's mostly for dealing with strings. Not anything else. Dealing with vectors, you're on your own. So let's actually create a new Rust file for just our FFI types. Then we're gonna copy all of this into here. Put this in a mom. BraneEngine FFI types. Make this public. And then we need to include these two things, I think. Now we should be able to go use that. Still not finding it though. I have to put this in here. Oh, so I have to say it's within the same crate. Nope. Do not care about promotion. There we go. All right, where were we? Ah, yes. So now we have module metadata. Let's create two other structs. One for a system definition. Actually, let's make a type for strings. That's essentially this entire thing, but with strings instead of vectors. BraneEngine string, mutable C char. You probably want to do FFI C string. Behind the scenes, this is a vector of unsigned 8-bit, basically chars, characters. So let's just have this be unsigned U8. Because C string is bytes, I think. Only need index. Actually, let's look at what indexing for strings looks like. So those are range indexes. How do you deal with characters? Oh, does Rust just use the str type just as characters? Well, let's see where this leads us to. Cannot find a declaration to go to. Value, we'll say U8 for now. Expected char, so we'll say char here. Still can't find a decoration to go to. Push, pop, remove, contain, insert. Wait a second. I haven't actually tried indexing into a string before. Are you able to index into string? Oh, so you just don't index strings in Rust. Okay. So yeah. Iteration. I'm still getting used to that. So you'd usually index it through an iterator. Now, it also would be fine just to have an opaque string type. Rest. Okay. So for now, we'll just have strings be opaque. And we'll say, type B equals string. Also say our string is cstring text. String. Import that. Because this one, cstring from pointer to and then if UTF-8 error, so I think that's the correct way to do it. We want to return null. This is an unsafe function, right? Is it an unsafe? Oh no, that is safe. It's from pointer unsafe. Or can we just do all of this in regular Rust? Okay, no. From pointer is an unsafe block. Then we can just use unwrap here, since we check if it's an error here. We can probably just go is error. because we don't actually need the value of the error. And let's put the toString here. And look at that. New BraneEngine string. Also do a get BraneEngine string so that we can actually read it in C++. But there is the issue of see. I think that's a good way to do it. Since we do actually need to output a C-style string, it's behind the scenes, it's a... Well, actually, let's just make it a C string. That way, we don't actually have to convert data types every time we use it, and we can actually return references. We can say into C string. It makes that a lot easier to deal with. And then I think we can actually return a char pointer from this. It goes well. And now we're just doing a little bit of API stuff between Rust and C++. Yeah, having a more chill day. So we can transform this into a raw pointer. But how do I just get the data? Constant C char. Okay, yeah, we do want this to be const. We also want this to be const. Can I say C string just as pointer like that? Okay, I can. So I think that's all the utility we need. To have this work. So if we say BraneEngine string here, okay, so that's not working. Interesting. We don't necessarily need that using statement at all. Actually, I can turn that off, can't I? We just say with using, no. There's a way to say not to export some stuff. See BindGen. Item types. At this point, it's probably worth creating a whatchamacallit, a config file. Actually, let's grab the data link to the default one somewhere. All right, here is the template one. There we go. Language, C++, namespace. Hello, how's it going? Item types. There it is underneath export. That looks good. So then I think in our build RS, we can say nice, or maybe not as nice. I don't know. With config. Interesting. Let's see. Here, let's say system def. I think BraneEngine string will be included now. Nope. So at the moment, we're working on interfacing a smaller Rust package into the bigger project. So we're doing a lot of binding generation between C and C++, with the end goal of being able to use this library to parse the metadata of Rust scripts. So I've decided the scripting system I'm going to go with is Rust compiled to WebAssembly, and then we're going to load that WebAssembly as a scripting system for the engine. So Rust already has a good amount of libraries for parsing itself, because, you know, Rust, you want to be able to parse Rust for macros and whatnot. So we're going to be using this small Rust package to extract some data about the scripts. It'll make it a lot easier to work with the compiled WebAssembly. So a little bit complicated and a little bit slow, but we're learning a lot along the way. Where you can find more info about what I'm working on. So since you're on the YouTube stream, you can actually find more info about it on this same channel. Though I haven't posted any YouTube updates on this project in a while, just because I've been researching a ton of stuff, and then work has been pretty crazy as well, since I actually signed on as a co-founder of the company I'm working at. So working on that a fair bit, as you would expect. And this is kind of just my side project at the moment. But yeah. And for those on the Twitch stream, I do think I have links to the YouTube. So the company that I am working at, or I guess, well, not all the paperwork has been done, so I don't actually own a part of it yet, but we have the initial, like, documents and whatnot. I mean, I could go through the investor pitch. I mean, we could do that. So yeah, Foundry, the WordPress of spatial computing. So it's what I'm trying to do with the game engine, but in Unity. So, you know, we got all the investor stuff, you know. Oh, it's so much money to, you know, make your own platform from scratch. But existing platforms, you know, they're so restrictive. Yeah, Daniel's still working on the pitch a little bit. But yeah, basically the idea is it's a Unity framework that makes it a lot easier to make multiplayer VR stuff. In the same way that this game engine hopefully will as well. Why is this complaining all of a sudden? In C string. We need this to actually be a struct. Yeah. That's interesting. I didn't think about, I haven't thought about linking the Twitch in the YouTube stream. I guess I could do that. I usually stream on both, though chat is a lot more active in, on Twitch, so I usually, like, I have both the chat windows right next to each other right here, so I catch everybody, but Twitch chat is the only one that pops up on the actual stream. So I usually do multi-stream, but yeah, let's drop a link to Twitch in our description. Edit. Put it right under the Discord link. There we go. So it should be in the description now. There we go. Struct BraneEngine string. Oh. Data C string. Oh, we need to do this. Here. There is a method with a similar name. Oh wait, it turns a box? Interesting. Okay, so it needs a box with the current type. Oh wait, that works. Data, box. I think we can just do data as pointer. Okay. String from pointer. Which naming convention? This one? I don't want it to be like super generic like that, because that's like, obviously that could probably clash with a lot of other stuff. Maybe BraneEngine new string. Oh, we can just do from raw. That's better. It was this an unsafe function. Yeah, the problem is that on the other side they're gonna see the BraneEngine string type. And it can't be a member, unfortunately, because that's not how the BindGen works. So I really don't want it to be like super generic, because then it might clash with other stuff. Yeah. Why does it need to be mutable? Is it because it's taking ownership of it? Yeah, it's because it's trying to take ownership of it. Oh wait, you're talking about within the method. Or members or whatever. Like that? All right, that makes more sense. String new. Can we say from? String. From pointer. Then from implies a cast, which is good. Or not cast, a copy. Right. And I agree. I was being a little bit lazy there. All right, so I think our C string API is decent now. Let's check. Is the include freaking out? Incomplete type. Yep, that would do it. Oh, I know what to do. We need to say, no, not no mangle. We need present C, and then this is still gonna be opaque, so it's still gonna complain about that. Right. Probably gonna have to make this a pointer. Actually, no, we can't even make it a pointer because then that's still over here. It's still an opaque type. And it's still going to complain that C string doesn't exist. Pain. So do I need... No, I don't want to make that a pointer. There's no reason for that to be a pointer. And for some reason, C string is just not showing up at all. Come on, let me just actually code instead of just doing FFI stuff. But now, do I just have to make everything in here a pointer? Well, this is an automatically generated file, so it doesn't matter whether I have it included or not. It's the library messing up. we make this a mutable C character, so I think this. So if we get string, we can call from raw data, and that's already a character. In fact, we don't need to do get string. Well, we do, because this is opaque. Actually, it's not opaque, so we don't need a get string anymore. String from so we now have this C string. To raw, this consumes self, and we get a character. I could. This is true. I feel like that's more steps though. From the moment. So this just makes sure that we copy the data, because we do want to copy it when we make a new string. Then let's also create a implementation of drop. Just say this is a C string, we drop it. So now we make sure this data never gets lost internally. And when we free the string, that makes sure we clean up the data. And we only need the free and new, since they can just directly access the C string. Look at that. That looks good. Well, I feel like this is going to... No. We don't want this to be... null per se. What is the type here? Okay, so we can just do a regular string. Then wait, does this return an option? It does. That's kind of funny. So that's like a null terminated string there, always. We'll return as C string, say. Probably want to return this as an object. Oh, it is a reference still. Hello. How's it going? this will always be valid. Make sure we're handling memory. Okay. How are we doing over here? Oh, I did say hi. At least I thought I did. I might have hallucinated then. All right, I think we can actually, now that we have our basic FFI types, we can actually get around to implementing stuff. After much too far into the stream. Let's see, we're gonna say let metadata equal module metadata new. Oh, have I not implemented a new yet? Looks like I have not. String. Up, back to types. Lent clone for string. That looks correct. Okay, so we do need to implement clone on this as well. Clone for vec type. Vector for raw parts, data. I'm gonna say this dot clone. Oh. Yes. So in Rust, it has a fancy thing where if you don't end a line in a semicolon, it just returns stuff. And it makes it so you can do super interesting stuff because even if statements and like unsafe statements are expressions. So it makes it so you can return from those statements. So like instead of doing a conditional, you can just do an if statement. But yeah, you can just go return like a normal sane programmer, but it seems this is like the regular standard thing to do. Okay, do we need to call collect on this? No, we don't want to. Oh, that just clones the iterator. Okay, I'm gonna have to look up how do you clone a vector in Rust. We have a vector of type T. And I can't just call clone? I thought for sure vectors would implement clone. Right. I might use ChatGPT if I get super desperate, but I'm not to that point yet. I find I learn better if I have to search for stuff. So if I did data, iter collect. Well, that's interesting. It is actually implemented. It's just clone. It's because I didn't specify that our type needs to be clonable. Not used to having to do this. I like that I like it, but it's been causing me trouble. Okay, so we can now derive clone. We don't need to clone that yet, so we're not going to add that. New is private. Most of these to be public. All right. Now do we get to actually do the coding we want to do? All right, there we go. Now, in build module metadata, we have metadata. Wait a second. Are you the guy that came into my chat a couple months ago talking about how you have all sorts of like Twitch hacks and whatnot? It's saying you're a first-time chatter, but also saying that you got your Twitch account back might have reset the first-time chat thing. Nope. Okay, you're a different guy. Okay. Okay. See, it's not in the current scope. It's probably no, it's not. Why do I keep forgetting functions? Well, it's because I'm not used to Rust fully yet, but... So we can do box from raw. Box. Oh, it's static. Expected. Huh. Metadata or oh wait, did I already turn this into... Oh no, I just want this to return module metadata. We don't need to do all of that. Copilot's trying to kick me in the knees. Okay, so we have our metadata. Now, instead of all these print statements, I'm gonna leave that there for now as like a to-do. So this is what we use to detect if we have an attribute that is a component. Let's actually make this whole thing, let's make this whole thing a function. So we have item, attributes, so let's say vec attribute. Contains attribute. Did this just do all of it for me? It didn't, I don't think. It copied some of my code here, but not this match statement fully. Oh. We did. Okay. Just iterates through the list. This looks correct. Looks correct. So I'm actually going to do something fancy here. Search directory is a string, and we return a result here because we want to be able to regular Rust code here. Okay. result module of metadata. And then what sort of error do we return here? They're just like a generic error. Well, that's IO. Rust. With a generic error. Okay, so there's a standard error. Interesting. I'll have to learn more about what dynamic is. I guess the way to do this is to have it be a box error. That seems to play nicely with the question mark operator, which is good. Now what we're going to do is call build module metadata internal. toString if this error. Call and wrap there since we've already checked it for errors. And then let data equal whatever that result is. Otherwise, there we go. That takes care of all the error checking we need to do on that side. And now we can code this just like regular Rust, for the most part. Hopefully. For definition in definitions. Oh, it's because, okay. Just say metadata down here. Okay. That's weird. Why isn't it letting me use the enumerator? Result. If okay as part of result. Oh, it's because I capitalized the K. That makes sense. Thing with similar name exists. So this is the syntax of our entire file. We iterate through each item in the file. Now we do have, I'm realizing we do have some issues in the fact that I won't be able to export any functions from implementations because of the no mangle requirement. So my macros, on top of doing all of the on top of adding like the no mangle and extern to the functions, in the case of systems, no, not systems, in the case of components, what I'll probably do is add a couple public functions underneath them to be able to call the clone, clone and drop, because for my entity component system, I do need the constructors, destructors, all that good stuff. I might not actually need constructors per se because of how Rust works. Since in Rust it's impossible and safe for us to have an invalid value, that means it doesn't. When you move something into a variable, it doesn't matter what the previous state of that variable was. Whereas in my current entity component system, where I was just storing function pointers to a bunch of ways that C does stuff, I would have to first call the constructor on a component. And I know that there's like copy constructors, but I wasn't using copy constructors in the construction sense. So I would just call the constructor on the block of memory representing a component. I would then call either the move equals operator or the copy equals operator. In C++. I don't have to do that with Rust, so it's actually going to be... I'm going to be able to simplify my entity component system the way that it handles memory behind the scenes, just because of how Rust works on the backend, which will be pretty nice. So I don't know if I actually need constructors, because I can just make it so whenever you add a component, you actually have to provide the component itself, instead of saying add component and it just like creates a default version of that component. Instead of doing that, I can just force people to always provide valid data. Which makes stuff easier for me. Less easy for the user, in some very rare cases. But that also means I don't need to iterate over implementations, because components and systems will never ever be in an implementation. Yeah, it should be intuitive for people familiar with Rust. It's a learning curve. I'm gonna put a lot of effort into making sure that it feels intuitive, but for now we're going for MVP, and then we'll massage it a little bit. We'll massage it. It'll be usable, hopefully. But yeah, the idea is that what it looks like to the user is, okay, I want to have a function called from the game engine. So in entity component frameworks, which is what I'm using, any behavior is called a system. So to define a system, you just have this macro, you plop this on top of a regular function, and you're good to go. That's the idea that I'm going for. That's the idea we're going for. So instead of having to do a bunch of like boilerplate, this just does it for you and extracts stuff manually. So going back over to our metadata parser, for now we'll just extract component types. And eventually this will also be extracting members as well, so we can interact with them in the editor, which will be super important. That's not important yet, though. Now we still need to, so I'm thinking about how do we interact with this from the editor? Do we need to interact with the data inside of them from the C++ side? Or can we just get away with only messing with it from the Rust side, except for in rare circumstances like native types where I can manually create the binding generations, like for the rendering system and whatnot. I still want a default editor for stuff. I'm thinking, do we define the way to edit components in the editor? Do we define that on the Rust side or on the C++ side? Does it just, I feel like for custom editors, it's definitely on the Rust side, for if we do even provide that functionality. For a default editor, it's possible we could get the macro to generate a, it's possible we could generate Brane. We could generate default editor scripts, editing stuff on the Rust side. I don't want that editor scripts to be part of the default binary though, so that would actually add a ton of complexity. Okay. We'll figure out a way. I already have versions of this for when I had a custom scripting system. So we'll probably just use that, but I do feel like we do extract members here later. For now, we extract names. So using our function we defined before, if contains attribute component, then what we want to do is on our metadata, dot components, we want to push a new value. Want this to be component def. It's actually ECS, so let's order these in the other direction. So this is our component definition. We have our name. We don't need components there for now. For now, name only. Component and system. Component def. Did I make an implementation of this for... No, we didn't. Okay, so how do we do from implementations? Implement from, and then can we implement it for only one type? From string for oh, so these are made public by default. That's nice. Unnecessary visibility qualifier. I guess traits would be public by default. That makes sense. It's just for the default implementation stuff. Or not default, the native implementation? I don't know. So from string, C string, new. Is there a version of from? There's try from. Because this has a chance to fail. I think for now, this is fine though. I mean, if somebody puts an emoji in their implementation name, immediately this crashes. Sorry. In anything that would make its way to here. Like, if they put an emoji in the name of a struct, which I think you can, that would cause this to crash, because C-string can't handle emojis. A little bit, because the way Rust works, if one of these fails, the entire program crashes. So somebody could put an emoji in one of their scripts and the entire editor would just close. Is not too much of a concern because, like, if you're putting emojis in your scripts, the editor should probably crash. You know, just, hey man, that's not okay. Yeah, well, we'll let the entire editor crash. If you put an emoji into a script, that's on you, man. So right. That is a fair point. That is a fair point. The macro... Well, this is separate from the macro. This runs... It looks like it's the same macro, but this is running adjacent to the macro and using it as like a flag to trigger behavior. But you're right. We should have a way to... Yeah. To do is a good idea. If there is an... from toString. So what I will do is, instead of unwrap, we can do expect, right? So we'll actually have an error message of some sort people can deal with. Expect. C string in. Well, a better way to deal with this idea. Instead of string, we'll just say C string here. So now we can just say data is equal to string into raw. And then we're able to handle right. I guess it could. I'm probably being far too concerned about this, but I'm happy with this, at least. There still does need to be error handling here. I just don't want the error handling to be on the... Why is this complaining? Oh. That's why this wasn't throwing an error. Ident toString. Yeah, that's why we're still putting in error handling. String from, we can probably just do from string. ident is, oh, that's an identifier, so we do want toString. And then what is this? Okay, that just returns a string. Let's import cstring. So we have all of these. From raw. Can I just say to cstring? No. Why is this so difficult? Wait a second. We had this working. Why is there a toString on string itself? As string. Yeah. Oh, that's not equal. Okay. I was like, why is there just neh? Is neh. I was doing this conversion in the actual thing. cstring new. Can I just say new? I can just say new. I was overcomplicating that. That was on me. And we're just gonna do unwrap. At least the error will be thrown here. Actually, we could just go, if this is error, oh wait, since it's a functional, we can just say return. Okay. So there we go. Error checking. If this is an error, we return. Name is identifier. Into, oh, you have to unwrap still. To raw. Actually, no, wait, we can say from identifier unwrap. That's the way we want to do this. There we go. I do want to console.log. Does ePrint print an error? Prints a standard error. Yep. Convert identifier. There we go. Yep. So our metadata should now contain all components, and let's do the same thing for functions. Item function, attributes. This is a system. Ooh. Sig.ident should be what we want. Then we want to push this to systems instead. System def. Okay. Let's just check to make sure. Okay, that's all looking fine. So now, back in our WASM scripting tests, here in our call to this function from the C++ side, yeah, that's a good idea. Failed to convert identifier for system. Failed to convert identifier for component. Then back here, metadata. And then here we're just gonna print. Format this a little bit nicer. Components. Then we'll just say metadata, components, data, name, data. Looks good. Leave the index in there. Yeah, well, we can do that. It does look nicer to have the index. Yep. Then, just for optimization's sake, let's do a new line there instead of end line. Then we're gonna say found systems. And just change this to systems length and systems data. We do want an end line here somewhere. Yes?
Can I show you something?
Sure. I'll be right back. Sorry, my roommate had to show me his very cool League play. And it was actually pretty cool. Alright, where were we? Testing to make sure this works. Alright. Let's test it. And we get a... we get an error immediately. Let's go. So, components. Data is null. That's not great. That's not great at all. Wait a second. I have an idea. I bet consumes the box. Okay. So we are then responsible for the data. Well, I want it to always have data in there. So the problem is something to do with initialization or it being deconstructed. So length is still 0. Why did we... Length is 0, so why did we even step into here? That's not good. So metadata, components. Okay, yeah, look at this. This isn't valid data, so this isn't returning something valid. And what I bet is happening see, can I place a breakpoint in here? And it will still work. It'd be amazing if it did. Can't leak private interface. I thought it's public. Yeah, it's public. Wait, did I say create public? No, we want this to be full public. Anyway, that has nothing to do with that. So let's go to build module metadata. And let's see if we can actually place a breakpoint. Can't. What if I try stepping into it? We have new. And this doesn't need to be mutable. Okay, I think the debug info is possibly a little bit messed up there. Do we have anything from here? This shouldn't be printing out. Oh, wait a second. This only compiles and gets added when we run CMake. So my tool chain works. So now look at that, now the breakpoints work. Okay, so the problem was I hadn't actually copied the binary to the release build yet. So our code might actually just be fine. Let's see. Let's check, is metadata valid? That looks valid to me. Found two systems, test function and test function 2. So the reason why these aren't matching up is because the WASM file and the file I actually have copied into the build are different. So yeah, this WASM crate is copied from here, and then I just manually copied in this test script to test the executable. So let's see if it can grab the component as well. It probably can. Yep, there we go. Found components, test component. Well, there we go. There we have our tool chain. Or we have the proof of concept for the entire scripting tool chain. We're able to call REST functions from C++, which is the majority of our code base. We're able to get data back from it. We're able to pass data to it. And we're able to extract the metadata we need about the thing itself. Now, all of the work is going to go into streamlining this process, which is going to be a lot of work. A lot of work. The last thing I think I'm going to do this stream is start on that process. And what I'm going to try to do is get it so that these procedural macros are actually able to add in like the no mangle and extern identifiers or macros. I guess that's a question. Does it only do one pass? Okay. That's not what I was asking. Well, I mean, it would have to. I guess the main question I'm wondering is, does the compiler do multiple passes over the same function, expanding all of the macros? Because what if one procedural macro adds in another procedural macro? Well, I don't know the answer. Let's find out. So in here, let's just go into our macros, attempt to add those things to it, and then just see if it works. Because I know that there's a Wasm BindGen crate, and I would assume it's doing this behind the scenes. So we don't need to have this script definition thing anymore. That's being handled by our module metadata parser crate. We don't need this crap anymore. We don't need that crap anymore. I'm gonna keep the print token stream. I don't think I'm gonna do this by hand anymore. We're going to use the syn library. Sin. How are you supposed to pronounce that? Well, no, we don't want not working. We just want syn crate. Cyan. Does it tell us what it's short for? Or it's just, it's the SYN library, or syn library. Cyan. It doesn't matter too much. But since we're actually using it in a macro now, dependencies, we'll add it through the console. Then let's use in then parse macro input. Okay, this is macros. And we are going to attach this to BraneEngine source common. That's probably a very smart idea. More git commits. Yeah, let's create a checkpoint. This is BraneEngine API. Yes. Just comment this out for now. Actually, we don't need to. POC Rust crate go with that. Okay. We're not recording it anymore, so we can just straight up delete that. Okay. Yeah. And I have done that before on multiple occasions, so I appreciate the reminder. Cannot tell you how many times I've been like, all right, let's look at the last commit when I had it working. Ah, I have not made any commits for 3 weeks. I'm always like, I should be committing more. It's just, I should be committing more. Okay, so instead of doing all of this, let's just see how this works with the syn library. Hopefully it's a lot easier. Equal parse as item. Just have it as derive input. Oh, we don't want this as derive input. We actually want this as no. The proc macro as proc macro derive. So this would be attribute input, wouldn't it? But it doesn't have attribute input. We're not doing a derive macro. I know it does have issues with the different types of attributes. Oh, derive input is the only input type. Okay, example of a derive macro. Do you have any other examples? So we have parse for derive input. Let's find all the parse fors. Oh, that's only in this for derive. What else can we parse? Because there should be things other than just derive. Can we get away with just derive input? I think we can, since the input token stream. Oh, JetBrains does have that. And I have used it, and it has saved me so many times. But yeah, it has this local history thing. And this has... I cannot tell you how many times this has saved my ass. For now, we're just going to go derive input and see if that works. But no, I definitely should be committing more. Let's derive input. Yeah. Build the output. What is quasi-quotation? It's probably what I want. First, let's see what syntax actually... So it gives us the attributes on here, the visibility, the identifier, and then... What is data? Struct, enum, or union. Oh, I'm guessing you can't do derive on a function. So this won't work for a function. I wonder if I can just parse and then what if we just parse file? Because I want this to work on functions as well. Parse function. Syn parse. So we might just do parse. Because this takes in a token stream. What's the difference between parse and parse2? Okay, because this works on a proc macro 2 token stream. Okay, I just wasn't seeing that in the editor. That's what I thought it did. So... create syn thought that's what I used in... Where is it? Where are you? There it is. Parse file, syn item. It's right there. Oh, it even shows up in the... Oh, it's probably just that it isn't finding it in the parse library. Oh, I think I know an easy way to deal with this. So we probably need to say exactly which item we want to do. So for component, we want struct. Nope, that doesn't do it. Derive input, syn, parse input. So if we just say item. Oh, we can probably say item struct here. And then it's not finding item struct, even though it's literally right. Okay, so we got const. Where's struct? There it is. Now, which module is this inside? I don't know. Let's just do item, struct, and let... Oh, it's just in syn. Oh, item, struct, in there. It's right there! Oh. Let... Found result unknown. Result T. Oh. Wait, still unresolved input. Used inputs. Item destruct is not in the root. The editors. Is it just not enabled? I bet it's that it's not enabled. Donald. So let's go into API. Say that instead. And maybe here item struct will actually show up. Yep, it does. Okay, so it was part of a great feature that hadn't been enabled. Now, if component is error, we're going to emit error for... Oh, that's cool. It actually gives the span of the error. So the source location of the error so I wonder, since I'm saying I'm trying to parse a struct here, if I put this component on top of a function, will this error reflect that we were trying to parse a struct? So if we go in here, and we say component, oh, file does not belong to any known project. We have BraneEngine, we have test WASM scripts, then we have two underneath here. Right. So now it's just not working. This should be fine. We're able to find BraneEngine and everything. So since I don't trust my actual editor, it actually is struggling to find the BraneEngine crate, which is here in BraneEngine API. There it is right there, BraneEngine. And in here, say we have these members, we have BraneEngine, and then in our toml here, we say we are importing BraneEngine from our workspace. Would it? Well, no. Macros wouldn't need to be a build dependency. They're just a regular dependency. Is there a problem that I changed the version? Nope, version is still the same. It's showing up here. So when I control click, it brings me here to external libraries, even though it's right here in the project. So it's saying that it exists. And then in here, nothing. Then in here, there it is at the the top. So it's being picked up. And if I click on it, it brings me here. Maybe if I try building the actual API. Then again, Rust should build it for the local thing. Yeah. Oh, this was working. It likes to just stop working though. Maybe we need to put this in a module. Okay, so we can't put it in a module, so that physically cannot be the problem. We don't need this anymore. Right. I think for the most part, this is the pretty standard way of doing it. Import resolution is stuck. Try simplifying macro imports. Okay, so if I say macro use and then BraneEngine, and this brings us to the BraneEngine module. No BraneEngine in the root. But we're importing it from here. Ah! Oh, so there's like some addition thing? Okay, what is the newest Rust edition so I can tell all my crates to use that? .2021 is the newest? Alright. Because I'm thinking that might fix it. .2032, yes. Let's use edition 2032. Okay. This is already using edition 2021. So it's something that I deleted from the others. From these. Oh! Look at that! That fixed it. Wow. Alright, note to self, don't delete random things from the project because you think it's just metadata bloat. Got it. It is interesting. Okay. Failed to parse component. Expected struct. Perfect. Error message couldn't be better. This could not... Yeah, look at that. Failed to parse component. Expected struct. And it even puts the error on function. Amazing. True, we could. To test emojis, we'd actually do it in this function, and this one right here. Because I know on Windows. Okay, so it's Control Plus. Maybe. It's not doing anything. Maybe that's for this specific. Oh, it's Control period? No, that's not it. Okay. Just grab this, Control copy, Control paste. Oh. Okay, so it's not even it's not even letting that compile. So instead, let's do invalid Unicode, I guess. Honestly, I think this is fine. I don't know, what's up with you? So it looks like emojis don't work at all. That might have been a Python thing that I thought also applied to Rust. Because, you know, Python. So I'm not actually sure how to invalidate that then. But it's good that we at least did some error checking there. Since technically could be an error. Technically. So in the case of that, the thing that could have been an emoji is the identifier of whatever that I thought could be an emoji, which apparently it cannot. Because I'm grabbing the identifier of the struct here, or the identifier of the function. Then again, parsing would probably fail. So the thing to error check probably would be this unwrap right here. So you should probably, you know, actually apply error checking to here. Let's see. Chinese characters. Let's test it. In WASM tests. Non-ASCII characters, but it is still showing mostly as valid. So if you run this, it still shows up and works just fine, it looks like. So, looks like it's valid. So you can code in Japanese, Chinese, all that good stuff. Probably some Arabic too. So I don't think we need to worry about that. It looks like that's going to mostly work. So we're going to say if let no. Also want to check to make sure that this is public. That's one of the things that I want to make sure of is, it just makes sense because I could add the public manually in the macro, sorry, automatically. But I want the user to set it to be public just because it makes sense. Component, oh. It's cool how you can do that, or you can just rename a variable. Visibility is an enumerator. Are there any fields for this? No. It's not equal to system visibility public. Can't be applied, right? See, aside from just using a full-on match statement, is there an easier way to do this? To check if it is one particular element of the enumerator? Because I think I know about if let, but that's for checking if it is one, but not if it's not one. Because I could go if so. Oh. Sin visibility public. So this checks if it is public, but I want to throw an error if it's not public. So Because I think the let statement doesn't automatically get turned into a Boolean. It's an if-let statement. So these two have to be right next to each other. So I can't pull a C++ and do that. I mean, I could just leave one side of this blank and do an else. But that is disgusting. I don't want to have to do that. So what we probably do is just a match. Just keep it easy. So for public, we don't do anything for this. We say component, ident, span. Or do we put it on the structure? We'll just put it on the identifier for now. So that takes care of the main checks I want to do. Make sure that this attribute is actually placed over a struct, and it is a public struct. So going over here. See, test component, components must be public. Yep. So now we get on to the, how the hell do we edit this? Can we let the result of this be mutable? Okay, we can say that this is mutable. And then we can push. Is that how I would do this? With the parse quote? So it is part of the SYN library. Alright, so I think that is the correct way to add an attribute. We just say push an omangle to the attributes. We also want to say well, I guess that is a question. What is an extern? What type of token is extern? Where does that show up in this whole thing? Actually, this is a component. We don't extern it. Never mind. So we actually wouldn't put no mangle here. We would put reproduce C. which is the majority of what we need to do. And then eventually in here, we can also make sure member types actually they might I'm gonna put a question mark there because it's possible that it's possible that we don't need to worry about this. That would just be for public editor components or an automatic editor inspector would care about this, but not much else, because we can just opaquely copy this around inside of our entity component system as long as we have as long as we have all the functions we need to copy it around, we're good. That's most of what we need to do here for now. Not all, because we still need to do this whole thing. Functions are going to be the fun part. And let's clear this out. I don't ever really search through my to-dos ever. This is more so, it's more so the mental act of writing down a to-do, because I will come back to this later, because this is required functionality to get it working at all. So this is more so a placeholder then for me to actually use it to find where I'm coming back to. If I did search through it, I would take your suggestion. But yeah, there's no world in which I don't come back to this and add it, because I need it for the thing to work at all. Failed to parse system. So we want to match system. So we want to push the no mangle attribute. We also want to how do I say that this is? Oh, come on. Give me the better. I want the editor's thing. Dang it. Here, Copilot, if you want to do it. There you go. That's what I wanted. Just option, ABI. It's a list of tokens. So this should be able to handle whatever. Rust. Show expanded rows. If we go to test WASM scripts, and we want to run this on the... Actually, can I run the same command on test scripts one? Test scripts one. Oh, that's in macros. Only accepted on the nightly compiler. Okay, so it's complaining that we don't have the... Hello, Square Peg, how you doing? Long time no see. But yeah, why could not compile? Because error the option Z is only accepted on that with compile. Okay, so it's just not, why isn't this red? It made me look dumb. All right, so unpretty expanded, only accepted on the nightly compile. So there's not really a way to test 100% that that is working. But if we just build it, and let's take Wasm Crate 2, drop it in Wasm Tests. Let's just call it Wasm Crate, overwrite, and let's see if it actually, let's see, test scripts 2. Let's see if we actually get test function 3 and test function 4 in our output. Because if we do, that means it's working. If we don't, it's not working. It's just not working. So let's see if that command works better. Now only available on nightly. Will the macros work? We are missing the R at the beginning. There we go. Unrecognized option pretty. Okay, so we didn't get any complaints. Oh, I'm dumb. I know what's going wrong. Look at this. So we do all these edits to system, and then we return item, the thing that was passed in. So it doesn't actually change anything. What we want to do is system, into token stream. Found token stream 2. Oh, so that just converts it. The token stream that they're using here is proc macro 2. What if we remove the 2 tokens? We just said into here. Token stream. Well, did that just add that back? Yeah, it did. Let's see what this whole thing suggests. Oh, we just say token stream from. Okay. So we're not directly using it. We're using quote. Okay, there has to be a way to convert this, aside from private functions. Still the private 2 tokens. This looks like it would work. What's the normal way of doing this? With generics. Okay, so if I just said let out equal and just put system in there. So only provide parse quote and parse quote spanned. Oh, so parse quote works with variables too. If I were just to say out parse quote, Wait a second. But in the example that they give us, oh, they're using regular quote there. Oh, yeah. Oh, consider giving out an explicit type. It is a item function. Still doesn't work. I think we need this quote library. So now if instead of parse quote, we just say quote here. It's not complaining. Okay. Look at that. It's actually working. You can see we got no mangle, public extern, on function, test function. Amazing. That's exactly what I wanted to do. It's a lot easier than manually working with token streams as well. And I'm also going to just copy this over to here. Even though we're not using any of it yet. Even though we're not using any of it yet. Just so that in the future, well, actually, we are using it for this reproduce C, or whatever that stands for. So yeah, now our component has a standardized layout, and our functions are properly set up to actually show up in a WASM binary. Now, if we run compile script again, and we grab WASM crate 2, drop it in our WASM tests, build directory, go over here to WASM scripting tests, run this. Look at that, we get test function 3 and test function 4. Working. Exactly how intended. So now we have the two different parts of it. Now, the one thing that I do need to add now is, actually, you know what? Let's see, how much time do I have? We have enough time. I can at least take a stab at it. Let's try creating bindings for constructors and destructors. So that's what you would call it in C++. Here it would be the move implementation. Oh, yep. Thank you for the reminder. Auto generation of function sigs working. All right. Just got to the end of the playlist. It's about to repeat. I actually caught it right on the restart. So maybe let's find a new playlist. With a slightly different vibe to keep it fresh. There we go. All right, so we're gonna do this to do. So we have the component. And then we want to say we need to come up with a name mangling scheme. Or we can just say item function, or let moot component clone method. Clone meth. No. Method. It's not parse code. Let's do item function. We can't do new? Also vec attribute new. So we have attributes, visibility, the actual signature, and then I'm guessing the block is the body. I guess the main thing is with quote, well, with parse quote in particular. Are we able to append a variable on the end of another variable? Like, because I do want to do this with quote. So if we go no mangle, public extrinsic function, BraneEngine, clone component, but we need to add the actual name of the component in here. And into here. Actually, yeah, we probably do want to pass the identifier. Let's get rid of this. Let equal component identifier clone. Let's actually take this as a string. If we put ident there, that should still work. Clone component ident. Am I able to do that? It doesn't look like that. All right, thanks for sticking around while you could. I do enjoy the tips and comments. So I'm glad you enjoyed watching as well. All right, let's see. So now we need to figure out, how do we create... Actually, we can just do the expansion outside of it. Let clone meth sig. I probably shouldn't have meth in my code. It's probably not a good idea. BraneEngine clone plus ident. So here we'll just say clone. We'll say clone method sig. We return a type of this identifier. For the entity component system, it would be the better way to do this would be to have immutable pointer to it. So let's do this. Destination is immutable identifier, and then we'll just have to this be a void method. And the reason why I have them swapped like this is that's just I want this to be somewhat similar to malloc, so we're following the same pattern. My phone is buzzing. I'm getting pings. Many pings. All right, back to code. So we're gonna say source. Now wait, we're gonna say destination. And I think we automatically dereference stuff in Rust. So if we say destination is equal to source.clone, I feel like that should work. And then we also need the drop method. Does that work better? There we go. That seems to be happy. So now we also need a drop method. Let we have BraneEngine drop, and then the name of the component. Now there's room to add to this mangling scheme. Say the drop method sig. We'll just say data for now. We'll actually say component. I will just say drop component. Now let's see what reaction we get from this. So we do get errors. Expected identifier found BraneEngine test component. So the majority of this project is C++, and then I'm starting to add Rust in for some parts of it. And then we're also using Rust as the actual scripting language for the game engine. So eventually I see Rust slowly taking over the project, but for the moment, we have a ton of C++ with a tiny bit of Rust. So that's why we have a CMake lists in a crate. So that is where my innovation comes in. It can't explicitly be used as a scripting language. However, you can... Nope. You can compile Rust to WebAssembly, and then there are plenty of WebAssembly, really good WebAssembly runtimes. So you can't explicitly use Rust as a scripting language, but you can compile it to WebAssembly and then use that WebAssembly as a scripting runtime. So technically, since I'm going to be using WebAssembly as my backend, I could use any language that compiles to WebAssembly, but Rust is going to be the one that we have the most support for. Expected identifier found BraneEngine test component. So let's see what this looks like. As expanded macros. So we get oh, the macro just doesn't complete. Because Lua isn't fast enough, and I really don't like dynamically typed languages. I need my static typing and large IDEs. And you know, Rust is about as statically typed as you can get. I like my code to work on the first try. I don't like having to rerun code over and over again to try getting it to work. The way that I'm architecting my engine to work is you're actually downloading a game as you play it from a specialized server. So let's say you have a huge open world game, you then load like the very small space around you instead of the entire game at once. So loading a DLL that you just downloaded over the network isn't the smartest idea for just not downloading a Trojan horse. So WebAssembly is actually meant for that purpose of being downloaded and not fully trusted. Because if you download a DLL that links to the C standard library, there goes your computer. So it's expecting an identifier. So I think okay. Then I think I need to do this with identifier as well. Though, I wonder if we can just say component ident. Okay, no, we can't. Theoretically, that works. Cannot find value dest in this scope. Expected type found that. BraneEngine clone test. Okay, so look at this. It's actually working for the most part. Like the drop function works fine. This is not. Oh. That would do it. Let's try running this again. And look at that. We automatically generate some bindings for BraneEngine test component, clone, and a drop. So that's very predictable names that we can use on our actual on the runtime side to use that on the editor side. And it didn't complain about setting destination to source clone. I hope it's actually setting the data inside the component instead of just copying the pointer, which actually thinking about it, this doesn't need to be mutable. Source doesn't need to be mutable. So let's test that theory. Because clone doesn't require mutable. Okay, yeah. No complaints. Serious macro. Okay. Now, the next step is compiling this to expected raw pointer, found raw pointer. Doesn't like that. So I wonder if the automatic dereferencing isn't. So not translate into a C++ class, except in very rare circumstances. The idea is this is the scripting system, so this component is a component for an entity component system, which means for the most part we can treat it as this opaque piece of data, and then call our auto-generated, call our automated clone and drop functions that allow us to interact with it, but we don't need to know about the data inside, and it's going to be the same scripts that for the most part are interacting with it. Now, for something like the rendering system, yes, I will have to recreate the component on the C++ side, but those are all native engine components. So for most of the time, we're not turning this into a C++ struct. Sometimes we will, most of the time we won't. Most of the time it's just going to be interacting with scripting and only scripting as a black box. At least that's my current understanding. So I think that that's just copying the pointer into the other pointer, which isn't what we want. The question is, do I just code it like C++? Like, when I put it in an unsafe block, does it suddenly become C++? Go to component. What if I say dereference this and set it to the result of source.clone? With that one little change, expected struct test component found a raw pointer. Interesting. So is it cloning the pointer when I call clone on this? Let's actually just, we can straight up copy this and test it out ourselves here. It's right there. Oh, it's probably because our macro is making it not exist. There we go. Dereference of raw pointer. Okay, so we can say unsafe. That was definitely missing. Expected that. So source clone. Is this cloning? I think that's cloning the pointer. So if we instead dereference the pointer, then call clone, we are now getting the no method named clone for the test, for the struct test component in the current scope. Which is the error we want to be getting. So if we had this, if we derive clone, this now works. And this is clone being called on the test component. Good, this is what we want. I guess we should also check the drop method. Make sure it's working the way. Yep. Can I put derived clone on this as well? Cannot move out of component, which is behind a raw pointer. That's probably complaining about the drop function. Boop. Yep. Which is behind a raw pointer. If we say unsafe, and then drop component, cannot move out of component, which is behind a raw pointer. Okay. Can I say drop component? Actually, I could probably do box from raw component. And then manually drop data. So this looks like it's what we want to do. It's back in here. Just say unsafe, let box data, drop data. And now, if we go back to test script, and we can delete that. The method named clone. So if I say derive clone, it all works. Look at that. All right, let's actually try building this. Fingers crossed it works. Following derives trait. Method clone not found for this struct. So if I do it in this order instead, clone is still not found. So it starts with the top one and then moves down, meaning that this should work because it starts with derive and then it's But then again, what we're compiling is the final results, the entire function. So if I were to go here, we have test component. See, and this is on test script 1, and this is test script 1. And look at that, we have clone for test component. Oh. Does order of functions matter in Rust? Okay, can I call C from A? I can call C from A. Which means order these things shouldn't matter because they're like, you're seeing the same thing I am. Like, there's the clone method. And then we call clone. Test component 2. Oh. Our problem is here. Different one. We're good. Nothing was actually broken. Okay, so let's grab debug wasm crate 2. Oh, copied the wrong thing. We want to copy the wasm file. Wasm crate. Now if we run our wasm scripting tests, look at that. We have our automatically generated bindings for clone and drop. I didn't expect that to be that easy, to be honest. And this answers another one of my questions. So in the source code, this is a pointer, but in WebAssembly, since this is a 32-bit WebAssembly binary, the pointers are just int32. Int32s. Yeah. Breast bosom 64 target. So we will have to be careful with passing memory to this. Since, you know, we won't be able to deal with the full 64-bit memory space. We only have 4 gigs of full size of what an i32 can handle. Unsigned 32-bit integer, I think. I do want to use this target though. Anyway, I think that's a good place to end this stream. We'll end on a commit. We auto-generate bindings for clone and drop. There we go. Well, I'll see you guys whenever I see you. I am gonna try to stream every weekend. I think that's a good goal to strive for, because I don't want to let all my stuff stagnate, even with work being as crazy as it is right now. So, yeah, I will see you guys next weekend.